Hello everyone, welcome to Civil Mania. So in today's lecture I'll be telling about, like in the previous lectures I have told about up to the construction of the A0 sheet, in which I have constructed in which I have shown the plans of these are the plans which I have shown: column plan, foundation plan, call layout, beam plan, slab plan. So in my today's video I'll be telling about how to analyze the building. So as you can see here, this is the ground level of the building, and whereas this one is the floor plan. So first you need to go to the load cases. You can see here in the analyze tab the load cases are present here. Simply go to the load cases and add this load, such as dead load. This one is the nature is the dead load. You can select from here. Then category is dead load. And PW means the partition wall load. This one is also dead load. This one is also dead load. Then FF means floor finish. Then dead load. Then live loads. Then roof load. This one is roof load, roof live load. Then earthquake load in the X direction, earthquake load in the Y direction. These are seismic loads. Then wind load in the X and the wind load in the Y. After that, delete the unnecessary loads and keep it only this load, as I have added this dead load, live load, wind load, roof load and seismic load. So only keep these loads and delete the other loads. After this one is done, then you can also even add here the load combinations by using the factor of the safeties, but I will show in a different video about the load combinations. After that, click on OK. After that, what you need to do is you need to go for applying the load. You have to as all of you know that before applying any load, we have to first of all provide the support conditions. After providing the support conditions to the building, we have to apply the loads to the building. Then after that, we need to analyze the building. So let me go to for applying and all the loads and the supports, we need to go to the analytical plan, and for that simply close the floor plan, then simply close the structural plan. We need to simply go to the analytical plan. In the analytical plan, first you need to show the 3D view of the diagram. As you can see here, this one is the 3D view of the diagram, and in this 3D view of the diagram, as the supports are already present here, you need to go to the 3D view, and in the 3D view there are two views. One is the 3D view and one is the analytical model. Simply go to the analytical model. As you can see here, this one is the analytical model. In this analytical model, you can simply do one thing. You can simply press the VG, visuality graphics, and in this one is the analytical model categories. Here you can also show the analytical notes. If you will click on apply, it will show you all the analytical notes, but it's necessary to remove the analytical notes, so I will remove it. Otherwise the diagram looks very haphazard. So remove the analytical loads. After everything is done, now you have to simply click in the boundary conditions. After clicking in the boundary conditions, as you can see here, this one is the fixed support. So you need to provide the fixed support in all the points. You need to provide fixed support in all the supports. as I am providing the fixed supports to all the supports, in this similar manner you have to provide the as you can see, I have provided the fixed supports to all the columns present here. Okay, after providing the fixed supports to the columns, these are the columns which are a bit longer than the rest of the columns, because these are the columns for the multi-level. Now after providing the fixed supports to all the columns, now what you need to do is you need to go to the again to the analyze part. After going to the analyze part, now you need to go to the loads. After going to the loads, you need to select the analytical level ground floor. First select the ground floor analytical level. After selecting the ground floor analytical level, go to the loads, and after going to the loads, you have to apply the loads, such as I will apply the as you can see here, the line load is present here, so I will select the line load. After selecting the line load, I will apply the dead load. So I will apply the dead load. So let me apply the dead load from here to here, then from here to here, from here to here, and from here to here. These are the dead loads which I have applied and these dead loads I have applied only for this load bearing walls. Now I will apply this is what I have applied. Let me go to the analytical model and you can check here how I have applied the loads. Now again go to the first floor, and in a similar manner you have to apply the loads in the first floor as well. So let me go apply in the ground floor only. After I have applied the live dead load, then now let me again go to the analyze, then loads. Now let me apply and go to the line load, and after that let me select the partition wall. Now let me select the partition wall, and for that what I will do is, this one is the partition wall load, then this one is the partition wall load, then this one is the partition wall load, then all are the partition walls. From here to here partition walls, from here to here partition walls, from here to here partition walls. Those walls which are present in the inside there I will be providing the partition walls. After that, now I will provide the floor finish, and for floor finish I will be applying the, now let me click the escape button 2 times in order to go out of the command. Let me again check in the analytical model 3D view. See, I have provided now the partition. I have applied the dead load, partition wall load. Now I will apply the floor load. Now let me go to the ground floor. I will apply the floor load, and for floor load you have to select the area load, then floor finish. Now select the floor finish, but remember that for applying all the loads I will apply floor finish. So for floor finish here, how you need to apply, you need to, for applying how much load I will apply, I have to check for the thickness of the slab. Our thickness of the slab is 150 mm, so I will multiply 150 mm, that is 0.15 meter, into the density of the mortar which I will be using for floor finish, that is 20. So 0.15 into 20, that is 3. So I will apply the load of 3 in the z direction, minus of 3 0.00 kilonewton per meter square applied. Now I will select the rectangular area and I will select from here the rectangular area up to here. So this one is the load I have applied. Now click on yes. In the similar way, while applying the point load, that is I will edit it. The dead load which I have applied, the dead loads its intensity should be, how I will find out, as here -1 kilonewton is present, so I will find out the intensity of the dead load for the load bearing wall, as select the thickness of the wall as 0.3. The thickness of the load bearing wall says 0.3, that is 300 mm or 0.3 meter, multiply by the density of the mortar, that is 20. So it will come as 6. Now you have to multiply that by the height. Our height of the wall is let me check the height of the wall from floor to floor height what I have applied. So for that what you need to do is go to the north elevation, so 3500, so you need to multiply again along with that 3500, so 3500 mm, that one will be 3.5 meter. So 21 kilonewton is the load. So let me go to the ground floor. Here I have applied the load or let me do one thing, let me select this one is actually, let me select this load. This one is the floor finish load. Now let me go to the analytical model 3D, and after that let me select the dead load. Let me select the dead load. This one is the dead load. So after selecting this one, simply type SA or you need to select the dead loads of all, or simply double click it. After double clicking the dead load, you can see here I have provided the load of -1, so I have to apply the load as minus of, instead of -1 I have to apply minus of 21. How 21 comes as? Height of the wall 3.5 into thickness of the wall 0.3 into density of mortar 20, so 21. So minus of 21 applied. So this one is the 21 which I have applied. Also change other wall loads. This one is also 21 applied. I need to change the loading capacity of all the walls. So this one also 21. After that this one also 21 applied. So I have changed the load capacity of all the walls as 21. Now let me again go to the ground floor level. Now select all the walls. This one is the partition wall, and for partition wall the height is 3.5 into 20, density into thickness will keep as 0.15, so 10.5. This one keep as 10.5. 10.5. I will copy this one, apply it. I have applied it. Let me go to the analytical model. Yeah, after going to the analytical model, or let me go to the analytical model. After going to the analytical model, you can check here that for this 2 row it has been increased height because they have changed to 21. Now I have to increase the height of this one, this. Let me go to the ground floor analytical model and select it. Yeah, in this manner you have to select it and change it to I have activated the dimensions. Now let me check the in this 3, let me change it, or let me do one thing, let me select here dimensions to 10.50. in this 3 I have done. Now let me select this 3, here also change the dimensions to 10.50. Now let me go to the analytical model and check whether it's okay or not. As you can see here, now my height is increased. So this one, this one, then this and this. Yeah, everything is okay. Now I have applied the 3 kind of load. That is, one is the dead load of how much is the dead load? This one is the floor finish of -3. Then next one is the partition wall load of -10.50, and the next one is the dead load of how much is the dead load? The dead load of 21, -21. So I have applied these 3 loads. Now let me apply other load, that is I need to go to the analyze, go to the loads. After going to the loads, now let me apply the floor finish. Now let me apply the live load. Live load I need to apply in the similar manner. Live load as per IS code, that is IS 456, I have to apply the live load of 3 to 4. So minus of 3 kilonewton, not point load. This one will be the area load. So let me select the area load of live load and let me select as -4. Now let me select once again of 4, applied. This one is the live load I have applied. Now let me again go to analyze and apply the earthquake load. Now roof load I need to apply. Now I will apply the roof load. The roof load will be also the area load. Go to the load. Similarly, go to the load. After going to the load, then again you need to apply the area load of roof load of 2.25. Okay, apply it. Okay, after that you need to apply the earthquake load, and the earthquake load you need to apply it in all the directions. That is, you have to apply the earthquake load. Earthquake loads are always, as all of you know, that earthquake loads are actually the lateral loads. So you have to apply the lateral loads in the, suppose earthquake load in the x direction. So you have to apply the earthquake load of -10 intensity, but not in the z direction. Here you type it as 0. You have to apply the earthquake load, as this one is in x direction. You have to apply it in the x direction. So for that, what you will do is, in the x direction, in the positive x, you will apply 10. Line load. Select the line load. Then after selecting the line load, first select the line load. After selecting line load, select the earthquake load. After selecting earthquake load, make this one as 0 and make this one as 10 in the positive direction, and apply it. After applying, you need to apply it from here to here. Now you need to apply the in the x direction, that is -x direction. So this one is the earthquake in the x direction. So I will now apply in the -x direction. So I have applied both the loads. Now let me select the earthquake in the y direction. So in the y direction, make this one as 0 and select this one as 10. So now in the positive x, this one is positive x. Now in the negative y, positive y I have done. Now negative y. So this is how I have applied the earthquake load. Go to the analytical model and check how the earthquake loads are being applied. In the similar manner, you have to apply now the wind load. So for that also you need to apply the wind load in the x direction and y direction as well. So for that, what you will do is go to the wind load, go to the ground level, and now again apply the wind load in the x direction. Similarly, you need to apply the wind load also, but here I will not apply it. Okay, after applying the load, you need to analyze it, and for analyzing the load, what you will do is, so for analyzing, see, as you can see here, there is no analysis tab present here. So what I need to do is, if you want the analysis tab, because I have applied all the loads, after applying all the loads and the supports, you need to analyze. But remember that in Revit you have to install Autodesk another software. So for that you have to download the software, and the name of that software is, I will show you as I am downloading now. See, Autodesk Robot Structural Analysis. it is the same software from the Autodesk, so you have to install the same software as well, and you have to, after installing the software, you have to link this software to the Revit. After linking, one tab will appear here for analysis. After that only you can do the analysis in Revit structure. So hope it's clear to all of you how to do the analysis. So you need to wait for some moment till the software gets downloaded. After the software its downloading process will be over, I will install it and I will show you the new tab for the analysis, and I will show you the how to do the analysis and its procedure. But remember that in this building I have applied the loads only in the first floor, that is only, sorry, in the ground floor only I have applied here, but you need to apply in all the floors. As you can as I will show you in the analytical model in the 3D view, I have applied only in the ground floor. I need to apply the all the loads in the all floor. So in the similar manner you have to apply it. Okay, so now as you can see here, just now I have installed the robot structural analysis software. Remember that you don't, as I have already told, that you need to install the uh, robot structural analysis software, but actually it's not like that. For showing these two add-ins, you need to go to the Google. You have to download this add-in, Structural Analysis Toolkit 2019. You have to simply search like in this way, download add-in for Revit. After that, you have to install this add-in. After installing this add-in, it will show you the robot structural analysis, and after that, what you need to do is you have to simply